Good day, students. In this lesson, we will now go and explore the world of physics. Are you ready? I bet you are. For today, we will be learning projectile motion. As you can see, we have a coin. Toss it upward. Does it stay up? No. When it reaches its maximum height, it eventually will go down. What makes it go down? The answer is gravity. Gravity pulls the coin down. Things that are thrown upward will go down because of this force. Gravity also pulls us towards the earth. That is why we are not being thrown outside the space. What floor was your room when you were in grade 7 or 8? Was it on the 3rd or 4th floor? Which is easier, climbing to your classroom or going down to the school canteen? When you climb in a high place, you go against gravity. When you are in a high place and you go down, you are moving towards gravity, so you use less force. Same is true with free-falling objects. Objects at free fall also exhibit uniformly accelerated motion. The acceleration due to gravity is 9.8 meter per second squared, neglecting air resistance. It is a constant acceleration for all falling bodies regardless of their mass and weight. All objects on the Earth's surface are being accelerated towards the center of the Earth at a rate of 9.8 meters per second squared. This means that if you raise an object above the surface of the Earth and drop it, the object will start from rest and its velocity will increase 9.8 meters per second. For each second, it is falling toward the Earth's surface until it strikes the ground. In general, a uniformly accelerated motion is the one in which the acceleration of a body throughout the motion is uniform. It can be observed in either vertical or horizontal dimensions and in 2 dimensions. Let us have an activity for you to understand the uniformly accelerated motion. Analyze each scenario. Identify if it exhibits uniformly accelerated motion or not. Let us have the first photo. Bikes at rest. Is it UAM or not? The answer, not UAM. Next, a truck running with a constant acceleration. Is it UAM or not? The answer, it is an example of UAM. Great job, class! You did well. Now, let us proceed. Let us take a look at this. As you can see, there's a man diving. The motion of the man as it dives into the water is moving along a curved path due to the natural force called gravitational force or gravity. Gravity is a natural force that causes objects to fall towards the earth. Hence, the acceleration due to gravity is always directed downwards. With this, the motion of the man undergoes projectile motion. Projectile motion is a form of motion where an object moves in a curved path. The object that is shown or projected and exhibits projectile motion is called projectile. The curve-like path undertaken by a projectile is called trajectory. Let us have another example. Are you familiar with this game? A sepak takraw player kicking a rattan ball over the net. What is the projectile in that scenario? If you think the rattan ball is a curved path, that is correct. In mathematical terms, we call this pattern parabola. An angle-launched projectile exhibits a full parabolic trajectory motion. This shows that as the player kicks the rattan ball in the air, the ball will eventually go back to the ground, still due to gravity, as it moves horizontally. Hence, projectile motion consists of horizontal and vertical motion working independently. The two pictures and scenarios that I have shown you are the two types of projectile motion: horizontal launch projectiles and angle launch projectiles. Let's take note of their components. In horizontal motion, it is the X component, no resistance in any form. To simplify, we neglect air resistance. Next, there is a constant horizontal velocity. We use Vx to represent it, V for velocity and X for horizontal component. Next, horizontal acceleration is 0. Why? Because if there is no external force acting along the horizontal motion, it means that acceleration does not exist, and it is represented as AX, A for acceleration and X for the X component. Next, we call the horizontal distance as range, and it is represented as dx, d for distance and x for the horizontal component. Now, let us go to the vertical motion. This is the y component. The force acting upon in this motion is the force of gravity, and it is represented as g, or acceleration in the y, or in the vertical motion, or acceleration due to gravity. The constant acceleration is always equal to 9.8 meter per second squared. But since it is a force going down, we consider it as negative. Take note, class, that negative indicates the direction, and the direction is downward. Due to the presence of gravity, acceleration at 9.8 meters per second squared. Due to the presence of gravity, accelerating at 9.8 meters per second squared. This caused the vertical velocity to increase, which makes it not constant, and it is represented as Vy, V for velocity and Y for the vertical component or vertical motion. Next, we call the vertical distance as the height, and it is represented as H or dy. For you to understand more, let us have an example scenario. This is an example of a horizontal launch projectile. Suppose you roll a marble on a frictionless table. Observe the motion of the marble as it goes down the floor. The motion of the marble is gradually increasing from point A to B due to the presence of gravity accelerating at 9.8 meters per second squared. This caused the vertical velocity to increase, which makes it not constant. For the horizontal velocity, there is no external force acting the horizontal motion, which means no acceleration resulting to a constant horizontal velocity. Take a look at this photo, class. What can you say? Which angle results in the greatest range? When we say range, it is the horizontal displacement, and as you can see, the farthest is in the 45 degrees angle. Next question. Which angle results in the maximum height? As you can see, it is the 75 degrees angle. How would you compare the distance traveled by projectile launch at 30 and 60 degrees? As you can see, they have the same range, same as 15 and 75. They have the same reach. In this scenario that I have shown you is also an example of projectile motion launched at an angle. And these are the possible results if you launch an object at different angles. Take note, class. Angle that is usually represented by theta is a numerical value in degrees expressing the orientation of the projectile to be thrown. To sum it up, the angle of release affects the range and height of a projectile. The maximum range is achieved if the projectile is fired at an angle of 45 degrees with respect to the horizontal component. An object launched at an angle of 30 degrees will also be the same if it is launched at 60 degrees. The angles 30 degrees and 60 degrees are called complementary angles because they adapt to 90 degrees. As the angle of launch increases, the vertical displacement of the projectile will also increase. At the highest point, the vertical component of velocity is 0, and the time to reach the maximum height is half of the total time of flight. In the elaborate section of this lesson, you can find sample problems related to projectile motion. Take your time to understand it. I know you can do it, dear students. And that ends our lesson for today. It has been a worthwhile experience being with you. Thank you for listening. This has been Sir Clint, reminding you till the end, continue to feed your curiosity in science. Until next time, bye!